Hello and welcome to another exam paper walkthrough. Today is Thursday the 8th of June. So this is the day after paper 2 was sat by students. Dr. Frost Maths have been right on the money and they've produced a really detailed higher paper 3 prediction paper. It's a massive paper, really nice. I formatted it a bit and put it into more of a sort of an exam style. But check their website out if you want to do this online. That's www.drfrostmaths.com. If you've not heard of Dr. Frost, where have you been? They're a fantastic revision site. I cannot recommend them enough. Like I say, it's a very long paper. So depending on time, I might split this into two papers. I'll obviously put all the links and discussion of that in the thread. Thank you very much for your time. Subscribe if you like, and we will crack on. Okay, question 1. Prove algebraically that the sum of the square of any two consecutive numbers is always a multiple of 4. So for this, if we're looking at even numbers, the first even number is obviously going to be 2n. So I'm going to call these numbers 2n. Well, I'm going to call the first number 2n. Let's get my pen on. So I'm going to call my first number 2n. And then the next consecutive even number would be 2n plus 2. Because we'd need to add on 2 to get the next even number. So prove algebraically that the sum of the squares, so I want to square them both and add them together, and I want to prove that it's a multiple of 4. So ideally, when I've multiplied this out and simplified it, I'm going to get something that can be factorized with a 4 outside, so 4 is a factor of it. But let's look. So 2n squared would give me 4n squared. And then if I multiply out this second bracket, that's going to give me 4n squared. Twice the product would give me 8n plus 4. And then when I tidy that up, I'm going to get 8n squared plus 8n plus 4. And then I can take a factor of 4 out and say that that's going to be 2n squared plus 2n plus 1. And then 4 times anything is a multiple of 4. Probably should have said 4 times any integer. So I'm just going to change that slightly just to make sure that my work is correct. So I'm just going to change that 4 times any integer is a multiple of 4. Okay, question 2. Given that the square root of x plus 2 is equal to 3a, find x in terms of a. So this is really asking us to make x the subject. So to do that, what I'm going to do first of all is square both sides. So x plus 2 is going to be equal to, this squared would give me 9a squared. Then I'm going to subtract 2 from both sides, so x is going to be equal to 9a squared minus 2. Right, question 3. Complete the table of values for, so I'm going to use the table function on my calculator for this. So to do that, I go menu, and I want the third mode, so 3, and then I want to type in the function of x. So this is kind of f of x means y in this case. So I'm going to go shift x squared minus 2x plus 2. So that's the function that I'm going to be looking for. And I want it to, I don't need a second function. I've got the option of adding a second function, but I don't want that. I want my value to start at minus 2, so negative 2. And I want it to go up to 4, and I want it to go in steps of 1, which is already set up for. And that gives me my table of values. So when it should say when x is minus 2, it's 10, which we've already got in the table. We've got then minus 1 and 5. We've got then 0 and 2, 1 and 1, 2 and 2, and then finally 4 and 10. I tend to say used table function. There's nothing that says that you have to do that. You're unlikely to lose marks, but particularly if you're doing this in class, it would be a good idea just to show how you got your answers. It is a calculator paper. You'll never get penalised for using your calculator, but it's best to show what you're doing. Okay, question 4. Here is the graph of y is equal to x squared minus 2x plus 2. What was the graph we just drew? That's the graph that we just drew. So use your graph to find estimates for the solution of the equation y is equal to x squared is equal to 4. So I think possibly we shouldn't have that there. Okay, so in effect, if I compare the equation to what I'm trying to solve, what I'm looking for is y being equal to 4. So if I find the point where y is equal to 4, let's see if I can do this and make it look neat. So if I insert a shape, I want to insert a line at y is equal to 4. Let me just make it a little bit heavier. There we go. So that's the line that I've inserted, and then I'm really reading off these values where the two lines would intersect. So it looks like we have an intersection here and an intersection here, and then I need to read those values off. So if that is 2, then we're going up in 4s, 0.4s. So that looks no, I'm going up in 0.5s. I do apologise. I've misread that. So that would be 1. So I'm looking at really minus 0.8. And x is equal to 2.7-ish for my solution. Right, question 5. This graph gives the volume of water in litres in a container at a time t seconds after the water started to flow out of a container. Use the graph to work out an estimate for the rate at which the water is flowing out of the container at t is equal to 12. So when t is equal to 12, we're going up in 1s. So I'm really looking for the tangent at that point. So again, I'm going to try and keep my working neat today. So if I place a line in to start off with, I want to just add a bit of weight to that. There we go. And then I want my tangent to just touch my graph at that point. So if I kind of look at exactly where I want to place it, that looks pretty good. And then I need to find the gradient of that line. So if I look at taking a large triangle to work out my gradient, so my gradient for that line is going to be equal to, it looks like 28. That's my change in y, divided by my change in x, which is looking at 30. And we'll use our calculator to get us a decimal value for that. So back into my calculator, wrong way around, 28 divided by 30 gives me 14 out of 15, or as a decimal, 0.93 reoccurring. So use your graph to work out an estimate for the water. So I'm going to say, that the gradient is going to be equal to 0.93, and I'll give my unit as litres per second. Okay, question 7. By completing the square, find the coordinates of the turning point. Turning point of the curve with the equation. So I want to complete the square on this. So this is quite a nice one. I want to really complete the square with these two terms. So when I complete the square, I would have an x and half that coefficient, so 5 squared. When I square out that bracket, that would give me x squared plus 10x plus 25. So I'd need to minus that 25. So that's just that bracket. So that would give me the same as that bracket, and to that I'd still need to add on an 18. So if we tidy that up, that gives us x plus 5 all squared, and then minus 25 plus 18 is going to give us minus 7. So if I want the coordinate of the turning point, the coordinate of the turning point is going to be found when this value is 0. So if you imagine it, it's going to be the very, very smallest value that x can have. So in this case, to make that bracket 0, x would need to be equal to minus 5. And when x is equal to minus 5, that makes this bracket 0, so y would be equal to minus 7. So that's the coordinate of my turning point. Okay, question 7. Here are 7 graphs. If we just talk, this looks like a exponential graph, negative exponential, linear. This looks like the tan graph. This is a reciprocal graph, and these two are cubic graphs. Complete the table for which letter each one could represent. So I said the exponential was graph A. I said that the graph D was the tan graph. So a cubic, and we've got 2 cubics to pick from. If we think when x is 0, we would have a y-intercept of 2, so we need a positive y-intercept, so that has to be graph G. I didn't write for some reason. And then that's my reciprocal graph, which was graph E. Right, question 8. The sketch shows a curve with equation of y is equal to k8 to the power x, where k and a are constants and a is greater than 0. The curve passes through the points 1, 7 and 3, 175. Calculate the value of k and the value of a. I really like these questions, and we don't get them very often. So I'll do my working up here. So if I'm looking at what, turning my pen on first of all. Okay, I'm using the equation y is equal to ka to the power x, and I'm going to use the 2 coordinates that I've got. So I've got the coordinate 1, 7, and I've got the coordinate of 3 and 175. So that's my x value, that's my y value, and I'm going to create 2 simultaneous equations. So first of all, 7 is equal to ka to the power 1, and then my second one is going to give me and my second one is going to give me 3, not 3, wrong way around, 175 is equal to k times by a to the power 3. Right, from here I'm just going to write this equation slightly differently. I'm going to write it as 175 is equal to k times a, or ka, times by a squared. So in effect, the reason I've done that is that's what this is equal to. So 175 is going to be equal to 7 times a squared. If I square root both sides, I would get 175 divided by 7 is 25, is equal to a squared. So a is going to be equal to plus or minus 5. We're told here that a is greater than 0, so I need to get rid of the negative version. So I've got when a is equal to 5, k is going to be equal to 7 divided by 5, which is absolutely fine as an answer. You could convert that to being 1.4, but I don't think it doesn't ask for decimal, so 7 over 5 is fine. Nice question. Okay, question 9. The graph of y is equal to f of x is drawn on the grid. Use the graph to estimate the value for f of x is 1.5. So again, for this, in effect, what I'm saying is I'm looking for the point where y is equal to 5. Where x is equal to 1.5. So I'm looking for the point where x is equal to 1.5. So again, if we bring in I straight line, let's try that again. So insert shape, I want a straight line. So 1.5 is going to be here. So I'm looking for where the graph and that line meet. So the graph and that line meet there, and that value is minus 2.8. So the f of 1.5 is going to be equal to minus 2.8. Okay, question 10. So this diagram shows part of the graph y is equal to x squared minus 2x plus 3. By drawing a suitable straight line, use your graph to find the estimate to the solution of x squared minus 3x minus 1 is equal to 0. Okay, so I'm going to write that equation just up here to help me out a little bit. So I'm looking for x squared minus 3x minus 1 is equal to 0. So I'm going to manipulate this equation to get this on my left hand side. So to do that, what I'm going to have to do is I'm going to have to add x onto both sides and add 4 onto both sides. So we should have x squared minus 2x plus 3 is equal to x plus 4. So now I need to draw that graph. So now I want to draw the graph of y is equal to x plus 4 and then see where they intersect, and then that's going to be my solution. So I've got an intercept of 4 and I've got a gradient of 1. So for every 1 across, checking my scale, I go up 1. And whenever I go back, I go down 1. So insert a line again. So I want to start here. So that's my line, and my intercepts are going to be that point there and that point there. So if I look at that, the points where they intersect are, and I just want the values of x to be fair. So x is going to be equal to, that looks like minus 0.2. And the other point looks like 3.2. So actually these are steps of 2, so that's more like 0.48. I'm going to go 0.7 and I'm going to go x is equal to 3.3. No, looking at this, I've done that completely wrong. I apologise. I was much closer with my first. So these are going in 2s, so that would be more like minus 0.3 and 3.3. Okay, question 11. equation of a circle is x squared plus y squared is equal to 42.25. Find the radius of the circle. Well, the general equation of a circle with centre at origin is y squared, x squared plus y squared is equal to r squared. So I want to find the square root of this. And technically speaking, I would have a positive and a negative value, but the radius is a positive value, so I don't need the negative. So r is going to be equal to the square root of 42.25. I'm sure we'd end up with a nice value here, 13 over 2. So 13 over 2, and I'm sure you'd be absolutely fine with, well, you will be fine with 6.5, but 13 over 2 would also be fine. Okay, question 11. Expand and simplify. So I tend to, particularly where I've got a 2 coefficient, use a kind of construction lines to help me out with this. So I'm going to have 2t squared plus 5t, plus 10t minus 3t minus 15. And when I simplify that by collecting the centre terms, I would have 2t squared plus 7t minus 15. Okay, question 13, expand, and we've got a triple bracket here. So whenever I'm expanding a triple bracket, I will always save my my easiest bracket for last. So that's just my personal preference. You could have done this a number of different ways. So if I expand these terms, I would get 6x squared, 3x plus 4x, so 3 plus 4 is 7x, and then plus 2. I have no issue with the grid method for this. I think it's quite a nice way. The construction line is okay, but can be a little bit confusing. I tend to do it this way. I will expand my first term, so that's going to give me 6x cubed plus 7x squared plus 2x. And then when I multiply by minus 5, I'm going to actually line up by my powers of x. So minus 5 times by 3 is going to be minus 30 x squared, and I'm writing my x squareds underneath my other x squareds. Minus 5 times by 7 is going to be minus 35x, and then minus 5 times by 2 is going to be minus 10. And then I just find that now I've got them lined up, they're easier to add together. So that's going to give me 6x cubed minus 23x squared minus 33x minus 10. Okay, question 4, factorize. So we've got x plus y squared plus 3 lots of x plus y. Okay, so they've both got an x plus y in common, so I can take out an x plus y as a common factor. Then that leaves me with x plus y plus 3. And I think that's as simple as I can go. Okay, question 15, fully factorize. So my highest common number part is going to be 9. So I can take 9 out as a common factor. They've also both got an AB in common. So what would I need to times 9AB by to get 18AB? That would be 2. And 9 to get 27, I need to times by 3. And AB to get AB squared, I need to times by B with a positive plus in the middle. So that's my factorized version. Okay, question 16. I've got my numbers mixed up there. Factorize. So 9p squared minus 1. So we've got a difference of 2 squares here. Minus 1, not the most obvious of squares. So that's going to be the square root of that, which would be 3p plus 1 multiplied by 3p minus 1. Okay, question 17, write as a single fraction in its simplest form. So for this one, I want to put them over a common denominator. The common denominator is going to be 1 minus x times by 1 plus x. So that makes my numerator. To put this over that denominator, I would need to times that by 1 plus x. And then to make that over that denominator, I would need to times by 1 minus x, which is already multiplied by minus 1, so that would be 1 plus x. So that's going to end up leaving me with that and that. That would just leave me with 2x. So I've made a mistake here. Let's go and rectify that. I times by 1 instead of by 2. So 1 times by minus 2 would be minus 2, and then 2 times by minus x would be plus 2x. So when I collect that together, then I'm going to have 3x minus 1 over, and then I'm going to leave it like that, although I could. Do I think it's trying to work out whether that would be simpler or leaving it as 1 squared minus x squared, or 1 minus x. I'm going to leave it like that. I think that's a simpler form. Although if you left it over that denominator, there's nothing wrong with that. I'm sure that's absolutely fine. Okay, question 18. Here are the first 5 terms in a number sequence. Write down an expression for the nth term of this sequence. So, right, let's look at the common differences first of all. So we've got a common difference of 4, 4, 4, 4. So that means that our sequence expression, so no equal sign, 4n, and then to get from 4 to 2, we would need to subtract 2. So that's my expression. Okay, question 19. Solve the simultaneous equation. So if I call that equation 1 and equation 2, so I'm going to start by I'm going to substitute sub y into equation 1. So that would give me x squared plus 3x plus 1, and that's going to be equal to 5. I missed my squared off there. So that's going to give me x squared plus 9x squared plus 6x plus 1 is equal to 5. So we're looking at 10x squared plus 6x, and then I'm going to minus 5 from both sides, so minus 4 is equal to 0. Okay, I'm going to divide by 2 as a starting point here because it's not going to affect my answer. So that would give me 5x squared plus 3x minus 2, and that will be easier to factorize. So let's just show divide by 2. Okay, so I'm hoping that's going to factorize, but we'll see. So the only way I can make 5x is 5x and an x, and the only way I can make 2 is a 2 and a 1. We're going to have one of them negative though. So if I go 5 minus 2, that will give me my values, and then to make x, just looking for working room. So I'm going to go, we'll do it here. I'll just squash it a little bit. So to make x 0 in this first case, x would need to be equal to 2/5, and to make x 0 here, x would need to be equal to minus 1. So we're using y is equal to 3x plus 1 to find our value for y then. So y is going to be equal to 3 lots of 2/5 plus 1. So 6 over 5. So we're looking at 11 over 5. And when we've got minus 1, so minus 3 plus 1 is going to be minus 2. So we'll set it out like that. So those are my 2 values, or those are my second 2 values. Okay, question 20, solve the equation. So I like these questions. So we're going to have to, I tend to times through by the denominator. So I'm going to times through by 2x minus 3 times by x plus 1 on both sides of the equation. I'd normally write that under both sides, but that's a little small at the moment. So that would give me, if I times this first fraction by that, the denominator would cancel with this part, so I'd just be left with x times by x plus 1. And then when I multiply by this denominator would cancel, so I'd be left with 4 lots of 2x minus 3. And that's going to be equal to 2x minus 3 times by x plus 1. So it looks quite complicated. Let's see how this works through. So that's going to give me x squared plus x plus 8x minus 12 is going to be equal to 2x squared. 2x minus 3x is going to be minus x. Let's just double check that. 2x times by 1 is 2 minus 3. So yeah, minus 3. I'm then going to take everything over to one side, and my goal really here is to keep my x squared coefficients positive, so I'm going to move everything over towards the right. So 0 is going to be equal to 2x squared minus x squared would give me x squared. These become 9x, so that would be minus 10x. And then minus 12, I'd need to plus 12, so that would give me plus 9. I then need to factorise that, so that's going to go into two brackets. And I'm looking for both brackets starting with an x. Two numbers that multiply together to make 9 and add together to make minus 10. It's going to have to be minus 9 and minus 1. So my solutions are x is equal to make that bracket 0, x would need to be equal to 9. And to make that bracket 0, x would need to be equal to 1. Okay. Question 21 then. On the grid, draw the graph of y is equal to 3x plus 2 for the values from minus 2 to 2. So I'm going to draw this from inspection. So the y-intercept is going to be 2. And then the gradient for every 1 across is going to go up 3. So 1 across up 3. 1 back down 3. 1 back down 3. So that's going to be my equation. If I can insert that as a line, add a bit more weight to it, and then I'm just going to change the position ever so slightly, make sure it goes through all of my points better. There we go. You can use your table function on your calculator for this as well if you wanted to. So doing it from a table of values, you type it in as 3 alpha x plus 2, nothing wrong with that, and then type in your values minus 2 up to 2, go in steps of whatever you want, but steps of 1, that will give you a table of values and they correspond as well. Okay, question 22. Find the equation of a straight line which is parallel to the line y is equal to a half x plus 2 and passes through the point 0, 4. Okay, so it's going to have the same gradient and it's going to have a y-intercept of 4, so that's quite nice. So y is going to be equal to a half x. That would make it parallel. It is parallel, not perpendicular. Parallel plus 4. Okay, question 23. There is a total of 45 boys and girls in a choir. The mean age of the 18 boys is 16.2 and the mean age of the 27 girls is 16.7. Calculate the mean age of all 45 boys and girls. Okay, so the way I'm going to do this is I'm going to say the total age of the 18 boys is going to be 18 times by 16.2. And to that, I want to add the total age of the girls, which is going to be 27 times by 16.7. And I want to divide that by the number. So that will give me my mean for the boys and the girls combined. So I'm going to type it into my calculator just like that. So I'm going to type it in as 18 times by 16.2 plus 27 times by 16.7. And I want to divide that by 45. So I'm looking at 33 over 2 or 16.5. Okay, question 24. So, some students were asked how many times they used their mobile phones last week. The box plot gives information about the male students' answers and about the female students' answers. Okay. Compare the two distribution represented by the box plot. So for your comparison, this is set out quite nicely for you. So this table helps us with our comparison. So the median for the males is looking at 40, and so is the median for the females. The range for the males, actually, I'd consider looking at the interquartile range. So the range, I'll add that on. So we're looking at, it looks like for the males, the range goes from 100 up to 100 and down to 10. So the range is going to be 90. For the females, the maximum value is 110. Minimum value looks like 4. So I'm looking at 106. And then box plots really are set up for interquartile range. So that's the difference between the bottom quarter and the top quarter. So the interquartile range for the males is looking like 66 minus 25. So we're looking at 31. And the interquartile range for the females is looking like 70 and the lower value is looking like 28. So we're looking at an interquartile range there of 42. So compare the two distributions. So that table helps us compare them. So they have the same mean. Sorry, not mean, median. And then your other two statements, females have a larger range. Have I spelled females right? Females have a larger range. And then my final statement would be comparing the interquartile range. So females also have a larger interquartile range. Okay, question 5. We've got a stem and leaf diagram. Work out the interquartile range of the stem and leaf diagram. Okay, so if we've got 25 seedlings, so I'm looking for to find the Q1, the lower quartile. I would be doing 25 plus 1 divided by 4. And then to find Q3, the upper quartile, I'm going to do 25 plus 1 divided by 4 times by 3. So that's going to tell me the position that I'm after. So 25 plus 1 divided by 4 gives me 6.25. That's more like it, 6.5. And then for the Q3, I'm timesing that by 3, so that would give me 19.5. So I'm after, for Q1, I'm after the 6th and the 7th value. and then I'll take the average of those, and then for the Q3 I'm looking for the 19th and the 20th value, and I'll take the average of them. Right, so let's look for the positions 1, 2, 3, 4, 5, 6, 7. That's quite handy. And then find the 19th and the 20th. If I go in reverse, if I've got 25, I need to go 5 and 6 back. 1, 2, 3, 4, 5. 1, 2, 3, 6, 7. So I'm after those two. That's quite handy. So the interquartile range is going to be equal to 57 minus 42, which is going to give me an interquartile range of 15, and the unit for that is millimeters. Right, question 26. Table gives information about time taken in seconds by 18 students to run a race. Work out an estimate for the mean time, giving your answer correct to 3 significant figures. So for my mean time, I want the midpoints. So that's going to be times by 7.5. This one it would be times by 12.5. This one would be times by 17.5. And then finally times by 22.5. And then I want to add them all together. So on my calculator, 1 times by 7.5 plus 2 times by 12.5 plus 7 times by 17.5, and then finally plus 8 times by 22.5. So let's just double check my typing in on my calculator. 1 times 7.5, 2 times 12.5, check, 7 times 17.5, and then 8 times 22.5. So I make that a total of 335. So my estimate from the mean is going to be 335 divided by the number, which I can get from here or I can get from here. Either way, it should be 18. That is 18. So divide that by 18, gives me a value of 18.61 reoccurring. So to 3 significant figures, that's going to be 18.6, and that's seconds. Okay, and question 27, find the lowest common multiple of 60 and 84. So I'm going to do this, it's calculator paper, so I'm going to take kind of a shortcut on my calculator. So 60 divided by 60 over 84 will simplify down to 5 over 7. So to find the lowest common multiple is either 60 times by 7, so numerator of 1 times by the denominator on the other, or it would be equal to 84 times by 5. Either way, that will give me the same value. So 60 times by 7, 420, or 84 times by 5, again 420. Okay, 28. Martin thinks of 2 numbers. He says the highest common factor, or HCF, of my 2 numbers is 6. The lowest common multiple of my 2 numbers is a multiple of 15. Write down the 2 smallest numbers that Martin is thinking of. The 2 smallest. Okay, so I've done this question quite recently. So in effect, what we're saying is that the intersection, if I was breaking these numbers down into their prime factors, the highest common factor is 6, and then those 3 parts would need to multiply together to be a multiple of 15. So let's call that n times 15. Let's do it as 15n. Right, for them to be integers, we can't actually have n being equal to 1 because 6 is not a multiple of 15. So my lowest one is when n is equal to 2. When n is equal to 2, that would mean xy times by 6 would be equal to 30. So x times by y would be equal to 5. So I'm after two numbers that multiply together to make 5. So that's going to be either way around. X is either 1 or y is equal to 5, or the other way around, but it doesn't really matter. And then that's part of the number. So if that was 1 and that was 5, then the actual numbers would be 1 times 6, which would be 6, or 5 times 6, which would be 30. So those are the smallest possible numbers. Right, question 29. Express 0.418 as a fraction. So this doesn't say using algebra, so technically I could do this on my calculator. Let's just show you 0.4, and then I want to shift, and then I've got a reciprocal button on my calculator, 18, so 23 over 55. Because of that, we don't tend to have, it normally says express as a fraction using algebra. If I was using algebra for it, I would have to say that x is equal to 0.418 reoccurring. I'd then say that 100x, so I'm multiplying it by something so that my decimal pattern repeats itself. So if I times that by 100, you can see now I've got my repeating pattern happening, and my digits line up. So I've got 41.818. I'm putting the reoccurring there and there. So 99x is going to be equal to these two values subtracted, so 41.4. So x is going to be equal to 41.4 over 99, which if we type that in, 41.4 over 99 gives us 23 over 55. Right, question 30. At the beginning of 2009, the value of a company was 250,000. In 6 years, the value of the company increased to 325,000. This is an equivalent to an increase of X% each year. Find the value of X, giving your answer correct to two significant figures. So 250,000 times by, and I'm actually going to call this value y for now. The reason being, it's not actually going to give us a percentage, so it's not actually going to give us x. Y to the power, and I'm sure it says 6 years, in 6 years, so 6, and that's going to be equal to 325,000. So if I divide both sides by 250,000, y to the power 6 is going to be equal to 325,000 divided by 250,000. It's going to be equal to 13 over 10. So I want the sixth root of that. So y is equal to, on my calculator, the sixth root button is this one here. So shift, and I want 6 root of my answer. So that's going to give me 1.0446 dot dot dot. So that's what it would be as a decimal, and x is the percentage. So if I in effect times by 100, I get 104.469. So my x value is going to be equal to 4.46975 dot dot dot. So to two significant figures, that's going to be 4.5%. Okay, question 31. Write 3 to the power n divided by 9 to the power n minus 1 as a power of 3. Okay, so I'm going to simplify this up slightly. So 3 is, 9 is 3 squared. So that's going to be, I'll write that again. So that's going to be 3 to the power n divided by 3 to the 2n minus 2. And then when we divide the powers, we subtract them. So that would be 3 to the power n minus 2n minus 2, which is going to be 3 to the power minus n minus 2. Actually, I've missed out my double negative here, so when I subtract that, that would actually be plus 2. So let's write that as 3 to the power 2 minus n. Okay, question 32, write this number in standard form. So in effect, I want the decimal to move to there. So 3.246 times by 10 to that, and I've moved it from there. So I've moved it 3, 6, 7 places. So that would be my answer. Okay, question 33, work out, given your answer in standard form, so I got tempted to do this without a calculator. We could do it without a calculator, but it's calculator paper, so 3 times by 10 to the power 7 divided by 6 times by 10 to the power 4. So 500. So given your answer in standard form, that's going to be 5 times 10 to the 2. And just the geek in me, I could do this without a calculator, so 3 divided by 6 is 0.5. And then times by my index power, 10 to the power 7 divided by 10 to the power 4 becomes 10 to the power 3. And then converting that becomes 5 times 10 to the power 2. So I could do that without a calculator. Okay, expand and simplify. So I've actually got a difference of 2 squares here. So difference of 2 squares would become, add them together. So 2 plus root 3 plus 2 minus root 3 times by, and then subtract them from each other. So 2 minus 2 is just 0, and then root 3 plus root 3 would just be root 3. So that's going to give me, would have made a mistake here, so that would give me 4, and that would cancel out, so we just have 4 root 3. Add them together, subtract them. Yeah, I've made a mistake here, so let's just think about that again. So a squared plus b squared is equal to a squared minus b squared is equal to a plus b times by a minus b. So if we add them together, so 2 plus 2 is 4, root 3 plus root 3 is 2 root 3. Sorry, no, root 3 minus root 3 is minus, so root 3 minus root 3 is 0, so I've got 4 on the first bracket. For the second bracket, I'm going to have 2 minus 2 is 0, 3 minus minus 3 is, root 3 minus minus root 3 is 2 root 3. There we go, that's better. So that should have been 2 root 3. So that's going to give us 8 root 3. Okay, and 35. The diagram shows a solid cone and a solid hemisphere. The cone has a base of x centimeters and a height of h. The hemisphere has a base of x centimeters. The surface area of the cone is equal to the surface area of the hemisphere. Okay, so we need the area for the surface area of a cone and the surface area of a hemisphere. So the surface area of the cone, so the total surface area of the cone is equal to the total surface area of the hemisphere. So I think the area of the surface area of a cone is going to be equal to pi r times by r plus square root of h squared plus r squared. The total surface area of the hemisphere is a bit more complicated. Well, not really. We need to, the surface area of a sphere is going to be equal to 4 pi r squared. So we need half of that, so we'd need to divide it by 2, but we need to add on the area of the circle, so we need to add on pi r squared. So I think that's going to give us the surface area of the hemisphere is going to be equal to 2 pi r squared plus pi r squared would be 3 pi r squared. Right. And we're told that those are equal. So let's look at that. So those are equal. So pi r times by r plus the square root of h squared plus r squared is going to be equal to 3 pi r squared. So we can cancel out by pi r straight away. Right, so we've got r plus the square root of h squared plus r squared is going to be equal to 3r. Right, find an expression for h in terms of x. Okay, so in effect, that's not too bad. So if I subtract r from both sides, I would get the square root of, and to be fair, I'm finding I should have used x instead of r, but we'll change that at the end. So h squared plus r squared is going to be equal to 2r. If I square both values, I'd get h squared plus r squared would be equal to 4r. So h is going to be equal to 4r. So h squared is going to be equal to 4r minus r squared. So h is going to be equal to the square root of 4r minus r squared. Okay, so I've made a slight mistake just here. So I'm just going to, what I've done is I squared this, but I didn't square my r, so that would be r squared, which makes this a lot more simple. So let's just take that line off. So h squared is going to be equal to, if I subtract 3r squared from, r squared from both sides, I get 3r squared. So square root both sides, I would get that the height is going to be equal to root 3 times by r. And then I've actually used x instead of r instead of x, so I think it should be that the height is going to be equal to root 3x. So I've overcomplicated that one. I was, I mean, that's fine. I've just realised I didn't actually need the circles at the bottom, because we've got circles at the bottom of each of them. So I could have made that a bit much more simple by ignoring that part there and ignoring that part there. But no drama. We got there in the end. Okay, question 36. So work out the size of the angle marked with the X. Okay, so we've got parallel lines here, so that angle there is going to be 38. You must give reasons for your answers. So I'm going to say that AED is equal to 38 degrees, and the reason being it's an alternate angle. So I'm going to say alternate to EAB. I'm then going to say that the base angles of an isosceles triangle are equal. So ADE is going to be equal to 180 minus 38 divided by 2. So that's going to be equal to 180 minus 38 divided by 2. So that's going to be 71 degrees. And the reason for that is base angles of isosceles triangle are equal. And then finally, so x is going to be equal to 180 minus 71. So that's going to be equal to 109. And the reason is that angles in a straight line equal 180 degrees. Okay, 27 sides of the angle are degrees in the quadrilateral are, and we're given them, use this information to write down an equation in terms of x. So angles in the quadrilateral need to add up to 360. So these would need to add up to x plus 2x plus x plus x. That would give me 5x plus 10 plus 90 plus 20 is going to give me 120. And that has to be equal to 360. So let's write the 0 better, 360. Right then, use this information to write down an equation in terms of x. So that's my equation in terms of x. I can go on and solve that, but that's as far as we're asked. Okay, question 28. Manchester Airport is on a bearing of 330 degrees from a London airport. Find the bearing of the London airport from the Manchester airport. So if we imagine we've got a bearing of 330. So that is Manchester Airport from London. So that's where London is. And that's where Manchester is. So if I want to work out the bearing of the London airport from the Manchester airport, I'm after this angle here. So I'm going to say that that angle there is going to be equal to 360 minus. So 360 minus 30 is going to be equal to 330. Sorry, 360 minus 330 would be 30 degrees. So that angle there would be 30 degrees. So Manchester would be on a bearing of, that's going to be a supplementary or co-interior angle. So 180 minus 30, so that's going to be 150 or 150 as a bearing. Okay, 39. So OAB is a sector of a circle with centre O and radius 7. The area of the sector is 40 centimetres squared. So the area of that is 40 centimetres squared. Calculate the perimeter of the sector, giving your answer correct to 3 significant figures. So we need to work out the angle before we can work out the perimeter of the sector. So we know that the area of a sector is going to be equal to the angle divided by 360 times by pi r squared. So if we're told that that's 40 is equal to divided by 360 times by 7 squared would be 49 pi. So if I rearrange that then, so 40 times by 360, and I want to divide that by 49 for now. So that doesn't tidy up very nicely. So I make the angle equal to that as an, which I'm going to leave as 14400 over 49 pi. So if we want the perimeter of the sector, so the perimeter is going to be equal to the angle divided by 360 times by 2 pi r, and then to that I would need to add on 2 lots of r, or 2 times 7. So let's see whether this works out nicer. So it should do. So if I am dividing that by 360, so if I take the angle and divide it by 360, that's my angle, but that would actually be pi. The pi's would cancel, so times by 14, and then add on 7 14, 2 lots of 7. So let's give it as a fraction first of all. So I'll make it 178 over 7, which as let's see if I can move that back. And then as a decimal, that's going to give me 25.4285 dot dot dot. Show that I've not rounded. So to 3 significant figures, I'm looking at 25.4. Try that one more time. Laptop's playing up a bit, not wanting to help. Okay. Right, question 40. The distance from F to G is 10 miles. The distance from G to H is 18 miles. Rakasha is going to drive from F to G. She will drive from G to H. She leaves at 10. She arrives at fullback. She drives at an average speed of 40 miles per hour there. Wants to get, by that time, work out the average speed. So if you think of it like this, if she's traveling at 40 miles per hour and she needs to travel 10 miles at that pace, that's going to take her, so speed is equal to distance divided by time. We want time, so time is going to be equal to distance divided by speed. So 10 divided by 40 is going to be a quarter. So a quarter of an hour is 15 minutes. So if she wants to get there for 10:35, she's only got 10 minutes left. So she's only got one, so 35 minus 15 is going to be 20 minutes. So she's got 20 minutes to cover the last part of the journey. The journey of the last part is 18 miles, so we need to travel at an average speed of 18 divided by 2/3 of an hour. So 18 divided by 2/3 is going to be equal to 27. That's not right. It's 1/3, not 2/3. So 18 divided by 1/3, not 2/3. That would be 40 minutes. So 54. So she needs to travel at an average speed of 54 miles per hour. Okay, question 41. A rectangle has an area of 4 meters squared. Write the area in centimeters squared. Well, 1 meter squared is going to be equal to 100 times 100, so 10,000 centimeters squared. So 4 meters would be equal to 40,000 centimeters squared. Okay, question 42. AB is the line segment. The midpoint of the line segment AB has a coordinate of 2, 5. Point A has a coordinate of 9, 2. Work out the coordinate of point B. So I'm going to do it like this. So 9, 2. We've got the midpoint of 3, 5. So the difference between those two coordinates is 6. So B must be 6 less than that. So minus 3. And then the difference between that is it's gone up by 3. So we go up by a further 3. So 8. Okay, question 43. So coach travels from D to L. The time graph of this journey is shown below. The coach stops at L for 15 minutes. The coach then returns to D at a constant speed of 42 kilometers per hour. Show this information on the travel graph. Okay, so we've got to add 15 minutes onto here, so that's going to take us to that point there. And then if we return at a speed of 42 miles per hour at 41, so that's going to take us half an hour. So half an hour is going to take us. So the speed is in minutes at the moment. So it's going to take us 30 minutes. So 30 from here is 10, 20, 30. So we're going to arrive slap bang there. So if I put that in with lines then, let's weight that a bit more. Is that working? Right, let's try that again. No. So that would be it. Those are shown quite lightly. I'm just trying to work out if there's a way I can increase them. We'll leave it like that though. Okay, question 44. Car travels at speed along a straight road. Work out the acceleration of the car during the first 5 seconds. So the acceleration is going to be the gradient of the line. So the gradient of the line is going to be equal to 10 divided by 5. So it's going to be equal to 2 meters per second squared. Okay, question 45. Find the total distance the car travels between the two sets of traffic lights. So the total distance is going to be the area, and we've got a trapezium, so it's going to be a half of a plus b times by the height. So this is a, this would be b, and this would be h. So it's going to be equal to a half of, we've gone from 5 to 15, so that's 10, plus 25, times by the height, which again is 10. So it's going to be 35 times by 5, which is going to give us 175 meters. Okay, question 48. Work out an estimate for the distance the car travels in the first 30 seconds. Okay, so for this, I'm just trying to work out whether it would make much of a difference to make it into stripes, but I'm not. I'm just going to treat it as a triangle. So I'm after the area of the triangle, so I'm going to say that it's going to be a half of 30 times by what looks like 9. So that's going to be 15 times 9 is going to be so 30 times by 9 divided by 2 gives me 135. So could have gone more accurate. We could have split it into 2 shapes and worked out the area of that, but I don't think really it's a 2-mark question. I think that's absolutely fine. Okay, question 47. So we've got 2 parallel lines. We've got the angle, work out the length of DC. So we want to work out this length here. So So if I work out the scale factor between the two shapes using this length here, so 15 divided by 10 is going to be 1.5. So I need to do 8 times by 1.5, which is going to give me 8 plus 4, 12 centimeters. Okay, question 48 then. Describe fully the single transformation that maps B onto C. So we've got translation of, and then we'll quote it as a vector. We've gone from there to there. So I've gone 4 across and 1 down, so 4 minus 1. Okay, question 49. Triangle A is reflected in the y-axis to give triangle B. Triangle B is then reflected in the x-axis to give triangle C. So we're looking at reflection in the y-axis followed by reflection in the x-axis. So reflection, reflection. So that's going to end up with a rotation of 180 degrees about the origin. So we could have done it rotation 180 degrees about the origin. I'm going to, rather than put the origin, because I think I've spelled it wrong, I'm going to go 0, 0. Okay, question 50. Describe single the fully transformation that maps P onto shape Q. So looking at it, we've got a P onto Q. So it's going to be a rotation 90 degrees clockwise, and then about the point. So about the point, if we think it's going to be about, it's not right, minus about the point minus 2, 3. Feel free to use tracing paper if you're struggling to find that center of rotation. Okay, 51. Describe fully the single transformation that maps A onto triangle B. So it's bigger. It's looking like we've got an enlargement. Just checking that 5. So let's put in better lines. So what I've done is I've joined up two similar points. Okay, so A onto B is going to be an enlargement scale factor of minus 1.5, because it's, and then about the point 1, 1. Okay, 51. Calculate the length of AB, so I'm going to call that x for now. So x squared is going to be equal to, we use an advanced trig here, 8 squared plus 9 squared minus 2 times 8 times 9 times by cos 40. So that's going to be 8 squared plus 9 squared minus 2 times 8 times 9 times cos of 40. So that's going to give me 34.689 dot dot dot. So x, the length that I'm after, is going to be the square root of that. So 5.8897 dot dot dot. So that's going to be 5.88 2.89 centimeters. Okay, 53, diagram shows the position of 3 towns. Calculate the bearing of Chorley from Acton. Chorley from Acton, so I'm after this angle here. Okay, so the way I'm going to do that is I'm going to work at that angle there would be 180 minus 37. So that's going to be 143, meaning that this angle here would be plus 150. So I'm going to do 143 plus 150. Type that in wrong again. So that adds up to 293. 360 minus that would give me 67. So that angle there is 67. And we want to work at this angle here. Okay, so I think I'm going to have to work out this length here first of all. So if I call that x, so x squared is going to be equal to 8 squared plus 9 squared minus 2 times 8 times 9 times cos of 67. So that's going to be equal to 8 squared plus 9 squared minus 2 times 8 times 9 times cos of 67. So that's going to give me the value of 88.73. So x is going to be equal to the square root of that. So 9.4199 dot dot dot. So I actually want the angle though. So that's the angle that I want. So the angle is going to be equal to, so let's rewind that slightly. So there we go. So sine of the angle divided by 9 is going to be equal to sine of 67 divided by x. So the angle is going to be sine to the minus 1 of 9 sine 67 divided by x. And I'm going to type it in like that. So shift sine fraction 9 times by sine of 67 divided by the last answer from my calculator, and then close up my brackets. So I'm going to get the angle there is 61.5786 dot dot dot. So if I want the actual bearing to that, I've got to add on 37. So that's bearing is going to be 098.578 dot dot dot. So the bearing to one decimal place would be 098.6 degrees. Okay, 54. Calculate the area of the shaded region. So the area of the so I'm going to treat it like this. Hopefully, can't spot any real issue. So I'm going to say that the area of the sector would be 35. So I'm going to say the total area of the shaded area is going to be equal to 35 divided by 360 times by the area of the shape, which would be 80 pi r squared. So pi times by 80 squared. From that, I need to subtract the area of the triangle, which would be a half of 80 times 80 times sine of 35. So if I type that in, then 35 over 360 times by pi times by 80 squared, and from that I want to subtract 0.5 times by 80 times by 80 times by sine of 35. So I'm looking at 119. Correct. So that's going to be 119.3241. So three significant figures, 119 centimeters squared. Okay, question 55. The length of sides of a triangle is 4.2, 5.3, and 7.6. Calculate the largest angle of the triangle, giving your answer correct to 1 decimal place. Okay, so the largest angle is going to be the angle in between the two shortest sides. So if I just do a very basic sketch, if I say that's 4.2, that's 5.3, and that's 7.6, the angle that I'm after is going to be that angle there. So that means that if I'm using the cosine rule, A, B, C, so I'm going to just slightly rearrange my formula. Look at the size of the largest angle of the triangle. So if A squared is equal to B squared plus C squared minus 2BC cos A, if I rearrange that to make cos A the subject, I would have cos A is equal to B squared plus C squared minus A squared divided by 2BC. So that's going to be equal to, and I'm going to just sub in these values, so 4.2 squared plus 5.3 squared minus 7.6 squared, and I want that divided by, just double checking that I'm happy with what I've typed in there, and I want to divide that by 2 times 4.2 times by, let's just tidy that up, I want that over 2 times by 4.2 times by 5.3 so shift cos of that answer gives me the value of 105.677. So to 1 decimal place, that's going to be 105.7 degrees. Okay, question 56. Diagram says a swimming pool in the shape of a prism. The swimming pool is empty. The swimming pool is filled with a constant rate of 50 litres per minute. Work out how long it will take for the swimming pool to completely full of water, given that. Okay, so we need the volume of the swimming pool first of all. So the volume of the swimming pool is going to be equal to the area of the face is going to be 1 times by 15, and plus that value there would be 1 plus a half of, and we've got a triangle, so that would be 6. No, it wouldn't be 6. So if that length is 15 and that length is 6, it would be 9 times by 1. And then I would need to times that by the 10. So let's give that a go. 1 times by 15 plus 0.5 times 9 gives me the value of, and then times that by 10. So I get the volume of the tank to be 195 meters squared. So from there, if it fills at a rate of 50 litres per second, so 195 times by 1000 will give me the number of litres, and I want to divide that by 50. So times by 1000 gives us that value, divided by 50 gives us that time. So 3,900 minutes. So if we convert that into hours, so I'm looking 0 hours and the answer minutes would 3,900 divided by 60 gives me 65 hours. Okay, liquid A has density of 0.7, liquid B density of 1.6, 140 grams of liquid A and 128 grams of liquid B are mixed to make liquid C. Work out the density of liquid C. So if I go A, B, C, and we've got density, volume and mass. So the density of 0.7, density of B is 1.6, we've got 140 grams. And we've got 128 grams. So we've got a total weight of 268. But we need the volume. So if density is mass divided by volume, then volume is going to be equal to mass divided by density. So 140 divided by 0.7 gives me 200. And then 128 divided by 1.6 gives me 80. So I've got a combined volume of 280. So the density is going to be equal to the mass, which was 268, divided by the density, divided by the volume of 280. So 268 divided by 280 . So work out the density of liquid C. So as a decimal, that's going to be I've got it exact as a fraction there. So as a decimal, 0.0. Uh, 0.957, and that would be grams per centimetre cubed. Okay, let's look at this one. So the diagram shows a container for grain. Let's just make this a bit bigger. We'll come to the calculator in a minute. The container is a cylinder on the top, and the cylinder has a radius of 3 meters and a height of h. Okay. The cone has a base of 3 and a vertical height of 4. The container is empty. The container is filled with grain at a constant rate. After 5 hours, the depth of the grain is 6 meters above the vertex of the cone. After 9 hours, the container is full of grain. Work out the value of h. Okay, so if we look at the volume of a cone, first of all, so the volume of a cone is going to be equal to 1/3 pi r squared h. So should we tidy that up a little bit? Yeah, so let's go 1/3 times by pi times by 3 squared times by 4. So those would cancel, so we're going to have 12 pi, I believe, for the volume of the cone. And then if we look at the volume of the cylinder, so the volume of the cylinder is going to be equal to pi r squared h. So we're going to say that pi times by 3 squared times by h, so we're looking at 9 pi h. Okay, so after 5 hours, the depth is 6 meters above the vertex, so that h would be 2. So after 5 hours, we're looking at the volume being equal to that would be 12 pi plus h would be 2, so plus 18 pi. So at that point we would have a total of 30 pi at 5 hours. That's how much would have been filled. So in effect that's the 5 hours. If we're leaving it for 9 hours, we can times that by 9 divided by 5. So the total volume of the tank is going to be equal to 30 pi divided by 5 times by 9. So the total volume is going to be 54 pi. Right, and we've already set up here that the total volume of the tank is this. So 9 pi times by the height plus 12 pi. It's going to irritate me. 12 pi is going to be equal to 54 pi. So if I minus 12 from both sides, I get that, actually I'll cancel pi. Let's see if I can. Right. So that would give me 9 times the height is going to be equal to 54 minus 12, so that would be 42. So the height is going to be equal to 42 divided by 9. Which is going to be 14 over 3. So the height is going to be equal to 14 over 3. And I'm going to leave my answer like that. Okay, that brings us to the end of this paper. Really good paper. Really enjoyed that. A lot of challenging questions. I hope you found that useful in your preparation. So just a reminder again, I think I'm going to link it into the video. This paper was from Dr. Frost Maths. You can do their online version if you would prefer that. Feel free to check it out. Thank you very much for your time in listening. I hope you found that useful in preparing for your paper 3. Good luck with that, and I will see you soon.